Hello everyone, in this video we're going to solve the 2026 AP Calculus AB exam. Question 1. This one is AB and BC. Male birds of a certain species arrive at a nesting error over a 30-day period. The rate at which the male birds arrive at the nesting error at time t days is modeled by a differentiable function m, where m of t is measured in number of birds per day. Select the value of m of t as shown in the table. Question A. Approximate m prime of 7.5 using the average rate of change of m over the interval 5 to 10. Alright, so we have m prime of 7.5. Look at 7.5 is between 5 and 10, right? So it's gonna be m of 10 subtract m of 5 divided by 10 minus 5, right? Now m of 10 is right here 16, subtract m of 5 is 7 divided by 5, right? So it could be 9 over 5, which is 1.8 birds per day per day. Now question B. Use a midpoint Riemann sum with the three subintervals 0, 10, 10 to 20, and 20 to 30 to approximate the interval from 0 to 30 of m of t dt. Alright, so we have interval from 0 to 30 m of t dt. We look at the table right here. 0, 10, the midpoint is right here, right? 10 to 20, the midpoint is right here, right? And 20 to 30, the midpoint is right here, right? So it's gonna be m of 5 times the width right here, 10, right? Plus m of 15 times the width is right here, 10, right? Plus m of 25 times the width is right here, 10, right? Now m of 5 is 7, m of 15 is 6, and m of 25 is 2, right? So we have 10 times 7 plus 10 times 6 plus 10 times 2. So it's going to be 70 plus 60 plus 20, right? It's going to be 150, right? Now question 2i. Interpret the meaning of interval from 0 to 30 of m of t dt in the context of the problem. So we need to say that the interval from 0 to 30 of m of t dt represents the total number of male birds that arrive at the nesting error over the 30-day period from t equals 0 to t equals 30. Now let's move on to question C. The rate at which female birds of the same species arrive at the same nesting error in birds per day is modeled by the function f defined as follows. How many female birds of this species arrive at the nesting error from t equals 15 to t equals 45? Alright, so technically you need to find the interval from 15 to 45 of 18 plus 16 sine of pi over 20 times t plus 15 dt, right? This guy right here, 15 to 45, right? Now since this one is calculator active problem, we need to print up the calculator, hit add calculator, right? So we're gonna hit the button right here, input the interval from 15 to 45. Now you're gonna input the expression right here. Then hit Control Enter. It's gonna be set for 1.859, right? But the question wants you to round your answer to the nearest integer. So it's gonna be approximately 642 bursts, right? Now question D. On the interval 15 to 30, the difference in the rates at which male and female birds of this species arrive at the nesting era can be modeled by the differentiable function d of t equals m of t minus f of t, where f is the function defined in part C. Is there a time t in the interval 15 to 20 such that d of t equals 0? Alright, technically, we're going to use the intermediate value theorem to do this problem. Alright, so at t equals 15, we're going to have m of 15 equals, we look at the table right here. M of 15 is set right here, right? F of 15, we're going to use the function right here, right? So it's going to be 18 plus 16. 15 plus 15 is going to be 30, right? Simplify this one, it could be sine of 3 pi over 2. But sine of 3 pi over 2 equals -1, so the answer must be 2, right? And then from these two guys, we can calculate d of t, right? So d of 15 is going to be m of 15 subtract f of 15, right? So it could be 6 subtract 2 is going to be 4, right? Now we do exactly the same thing for t equals 20. Then we have d of 20 is going to be m of 20 subtract f of 20, right? So it's going to be approximately -1.686, right? Now since d of t is continuous and d of 20 less than 0, less than d of 15, right? The intermediate value theorem guarantees there is at least one time t in the interval 15 to 20 such that d of t equals 0. Question 2. The function f is defined by f of s equals 1.43 to the x plus 0.57. And the function g is defined by g of s equals 14x plus 12 over x plus 12. The graphs of the function f and g intersect at the point 1, 2, and a, b. So this is point 1, 2, and a, b right here. For x greater than or equal to 0, the equation y equals g of x right here can be written as x equals h of y equals 12y minus 12 over 14 minus y, where h is a function of y. The graph of x equals h of y and the horizontal line y equals 3.5 are shown in the figure number 2 right here. This is 3.5, right? Question A. Let R be the region bounded by the graph of G, the x-axis, the y-axis, and the vertical line x equals 1, as shown in the figure 1. Find the area of the region R. So the region R is right here. And you know that the area bounded by the region R and the x-axis can be in the form 0 to 1, right? 0 to 1 right here. G of x subtract the x-axis, which is y equals 0, right? So top subtract bottom dx, right? So we're going to copy this one over here. And it's going to be actually in the row from 0 to 1, g of x dx, right? So we're going to print up the calculator. G of S is right here. Alright, so we're gonna hit add calculator, hit the button right here, input the interval from 0 to 1, right? And G of S is this guy, we just input this expression, right? Then you're gonna hit Control Enter. It's gonna be 1.513. Now question B. The region R described in part A is the base of a solid. For this solid, its cross-section perpendicular to the x-axis is a rectangle whose height is 1/3 times the length of its base in the region R. Write but do not evaluate an integral expression that gives the volume of the solid. Alright, so basically we need to calculate the volume of the solid using the cross section, right? So the region R is right here. Then the cross section is the rectangle, right? So it could be something like this. The base is the difference between G of S and the x-axis, which is y equals 0, right? And the height is 1/3 times the length right here, G of S, right? So the error is the interval from 0 to 1, length times height, right? So it could be G of S minus 0, it could be G of S times this guy right here, 1/3 times G of S ds, right? I copy this one down over here. Now question C. The shaded regions in figure 1 is bounded by the graphs of f and g on the interval from s equals 0 to s equals a. Find the error of the shaded regions. Alright, so s equals 0 is right here and s equals a is right here. Right? Now, from 0 to 1, we know that the function g of s right here is below the function f of s, right? So, we have the error is the interval from 0 to 1, we have f of s subtract g of s, right? ds. Now, from 1 to a, the function g of s is above f of s, right? So we're going to add the interval from 1 to a, g of s subtract f of s ds, right? Now we need to find the intersection right here. So we have the function f of s right here, and the function g of s is right here, right? So we're going to use the calculator to find the intersection, right? Home screen, go to graph. Alright, so I'm going to input the first function. It could be 1.43 raised to the s plus 0.57, right? And then press enter. It's going to be right here. Now hit tab, input the second function, and then press enter. It's going to be right here. Alright. Now we need to find intersection. We know that the intersection right here is 1, right? So we don't need to find this one. Now we need to find this guy right here. So press menu, analyze graph, number 4. Go to the left, go to the right of intersection. It could be 3.26, right? So A right here equals 3.26, right? So I'm going to copy this one over here. So I need to store the function. So I'm going to press home screen, go to calculate. Now I'm going to input f of s and press control the button right here. Alright, f of s equals and press enter. Alright, now I'm going to store the second function g of s. I do exactly the same thing, right? Alright, now you're going to press the button right here, input the interval right here from 0 to 1. Of f of s minus g of s. I'm going to copy this one over here. Interval from 1 to 3.26. G of x, subtract f of x, press Ctrl, Enter. X could be 0.632, right? Question D. Let T be the region bounded by the graph of x equals 2y. The y-axis and the horizontal line y equals 3.5, as shown in the figure number 2. Write but do not evaluate an integral expression that gives the volume of the solid generated when region T is revolved about the y-axis. Alright. So region T is right here. If this guy revolves about the y-axis, it could be something like this. Alright, now we're going to use the disk method, right? And the radius is right here. One, 2, 3.5 of x right subtract x left, right? All together square dy, right? So it could be integral from 1 to 3.5. X right is the function h of y right here, right? So we have 12y minus 12 over 14 minus y, right? Subtract x left, which is 0, right? And all together square dy. Don't forget to multiply by pi, right? So I'm going to copy this one over here. Question 3. This one is AB and BC. A pie is taken from a hot oven and put on a table. The internal temperatures of the pie at time t minutes can be modeled by the function h that satisfies the differential equation right here, where h of t is measured in degrees Celsius and h of 0 equals 75. This one is the initial condition. For t greater than 0, it's known that h of t between 20 to 75. Question A. Explain why the following could not be the slope field of the differential equation dh over dt equals negative 1 over 15 times h minus 20. Okay, so observe that the slope field given right here always positive, right? Look, use the Christmas tree trick. The lights going this way, positive, lights going this way, negative, right? Now, we look at this one right here. We see that h of t is always greater than 20, right? So then h minus 20 always greater than 0, right? And then a positive number multiplied by a negative number right here always less than 0. It tells us that every slope in the slope field should be negative. This one contradicts the given one right here, which is the given slope field shows positive slope, so it cannot represent these differential equations, right? Now question B. Find the slope of the line tangent to the graph of h at time t equals 0. Right. So we need to use the differential equation and the initial condition h of 0 equals 75, right? So it's going to be negative 1 over 15 times, substitute 75 for h minus 20, right? So it could be negative 1 over 15 times 55, right? Simplify this one, it's going to be negative 11 over 3. Or you can leave the answer like this, that's fine, right? Therefore, the slope of the tangent line at t equals 0 is negative 11 over 3 degrees Celsius per minute. Now question C. It can be shown that the second derivative of the function h is 1 over 225 times h minus 20. The line tangent to the graph of h at time t equals 0 is used to approximate h of phi, right? The internal temperatures of the pie at time t equals 5. It is approximation an overestimate or underestimate for the actual value of h of phi. Alright, now since h of t is greater than 20, right? So it tells us that h of t minus 20 greater than 0, right? So from these two guys right here, we can conclude that the second derivative of h always positive, right? This guy is positive, this guy is positive, so when you multiply, it's going to be positive, right? It tells us that the function h is concave up. So if the function h is concave up, it could be something like this. Then the tangent line should be below the curve, right? Therefore, the tangent line approximation at t equals 0 given an underestimate, right? Now question D. Use separation of variables to find an expression for h of t, the particular solution to the given differential equation with initial condition h of 0 equals 75, right? So we need to divide both sides by h minus 20 and multiply both sides by dt, right? So it's going to be, now we're going to integrate both sides. The left hand side is ln of h minus 20. The right hand side is negative 1 over 15t plus c, right? Use initial condition right here to solve for c, right? So we have ln absolute value of 75 minus 20 equals negative 1 over 15 times 0 plus c, right? So c equals ln of 55, right? So we're going to substitute this guy back over here. So we have, since the initial condition is positive, so we can eliminate the absolute value side right here, right? Now we just exponentiate both sides. So it's going to be h minus 20 equals e raised to the negative 1 over 15t plus ln 55, right? And this guy actually e raised to the negative 1 over 15t times e raised to the ln 55, right? And then this guy actually 55, right? So we can bring 55 to the front, right? So we have h minus 20 equals 55 times e raised to the negative 1 over 15t, right? Add 20 both sides, so h equals 20 plus 55 e raised to the negative t over 15. This one is the final answer. Question 4. This one for AB and BC. Let f be a tridifferentiable function on the closed interval -4 to 4 with f of 2 equals 3. The graph of the function f prime, the derivative of f is shown below. Question A. For x greater than 0, the function g is defined by ls minus lns. We need to find g prime of 2. So we need to take the derivative of g of s, right? So g prime of s equals f prime of s minus 1 over s, right? So g prime of 2 is f prime of 2 minus 1 over 2. Now f prime of 2 is 1.5 right here, right? Which is 3.5 minus 1/2. It's going to be 2 over 2 and it's going to be 1, right? Question B. Find all values of x on the interval 0 to 3 at which the graph of f has a point of inflection. Alright, so the point of inflection occurs when f double prime of s changes sign, right? So we look at the interval from 0 to 3 right here. Alright, so we only have this point right here, right? Observe that f prime changes from increasing to decreasing. In other words, f double prime of s changes from positive to negative, right? F double prime is the slope of f prime, right? So if the tangent lines go this way, the slope is positive. Tangent lines going this way, the slope is negative, right? Question C. for s greater than or equal to -4 less than 4, on what open intervals, if any, is the graph of the function f both increasing and concave down? When it comes to increasing function, f prime must be greater than 0, right? And concave down, f double prime should be less than 0, right? So we look at the graph right here. We need to find the interval where f prime of s greater than 0, right? And f double prime of s less than 0, right? Now you need to be careful. This is the function of f prime, right? So f prime of s greater than 0 when it's above the axis, right? So it's above the axis should be from here to here, right? Now f double prime of s less than 0, f double prime is the slope of the tangent line of the function f prime, right? So we just draw the tangent line right here, and we see that this guy is positive slope, which is greater than 0, right? F double prime greater than 0. Draw this guy. So we see that this interval right here, f double prime of s less than 0, right? Because the slope is negative. And this guy right here, the slope is positive, right? So the only interval that satisfies this condition is from 1 to 3 only, right? Which is this guy right here, right? It's above the axis, so it's positive, right? And the slope is negative, right? Now let's move on to question D. Question D is considered the most difficult question in this exam. Now, on the interval -4 to 4, find the value of s at which f has an absolute minimum and the value of s at which f has an absolute maximum. Alright, so basically, we look at this one right here, we see that this one is the closed interval. Think about the candidate test, right? First, you need to find the critical numbers, right? So the critical numbers occurs when f prime of s equals 0 or undefined, right? On the interval -4 to 4, f prime of s is 0 when s equals -2 and 3, right? Now we're going to use the candidate test. So we're going to sketch the table as follows. Now we need to take advantage of this guy right here. F of 2 equals 3. Alright, now we're going to use the fundamental theorem of calculus. So we have the integral from -4 to -2 of f prime of s ds equals f of -2 minus f of -4, right? So then f of -4 equals f of -2, subtract the integral from -4 to -2 of f prime of s ds, right? Now we look at the graph, integral from -4 to -2. This guy right here, below the axis, so should be negative, right? So f of -2 subtract a negative number is the same thing as f of -2 add a positive constant a, right? So this guy always greater than f of -2, right? Now the integral from -4 to 4 of f prime of s ds is f of 4 minus f of -4. So f of -4 is f of 4 subtract integral from -4 to 4 of f prime of s ds, right? Which is the net change of this guy add this guy, right? And add this guy, right? And you see that the error above the x-axis always bigger than the error below the axis, right? So this guy always positive, right? So f of negative 4 equals f of 4 subtract a positive number is always less than f of 4, right? Now from these two guys right here, we can conclude that f of negative 4 always greater than f of negative 2 and less than f of 4, right? We need to calculate f of negative 2, right? So we have the integral from negative 2 to 2 of f prime of s ds is f of 2 minus f of negative 2, right? So then f of negative 2 equals f of 2 subtract integral from negative 2 to 2 f prime of s ds, right? But f of 2 is 3, right? And the integral from negative 2 to 2 of f prime of s ds is the error of the region above the axis, right? It's going to be right here. And it's always positive, right? So 3 subtract a positive number is less than 3. At s equals 3. The sign of f prime of s does not change, right? This is still positive and this is still positive. So right at s equals 3, the function f does not have the maximum or minimum, right? At s equals 4, we have the integral from 2 to 4 of f prime of s ds equals f of 4 minus f of 2. And then f of 4 equals f of 2 plus the integral from 2 to 4 of f prime of s ds, right? Now, the integral from 2 to 4 of f prime of s ds, it should be above the x-axis, right? 2 to 4 is right here. So it's always positive, right? Now, f of 2 plus a positive number is always greater than f of 2, right? But f of 2 equals 3, right? So we can conclude that f of 4 always greater than 3, right? Now we're going to make conclusion. We have f of negative 4 right here, always less than f of 4, right? And f of 4 right here, always greater than 3, right? So this guy is the absolute maximum, right? And absolute minimum is right here, because this guy less than 3, right? So at s equals negative 2, right? So we need to make conclusion. The absolute maximum occur at s equals 4. And the absolute minimum occurs at s equals negative 2. Question 5. A remote control toy car moves back and forth along a straight path so that its velocity at time t is given by the function v, where vt is measured in feet per second and t is measured in seconds. Alright, so vt is right here. The graph of vt is shown below. Question A. Find the acceleration of the car at time t equals 1 second. Alright, so at time t equals 1 second, it should be this function right here. We need to find the derivative of this function, right? So we have a of t is v prime of t, right? And it's going to be 4t cubed minus 24t squared plus 32t, right? The reason why we use this function because t equals 1 is inside this interval, right? Now we have a of 1 is v prime of 1. It's going to be 12 feet per second squared, right? Now question B. is the car speeding up or slowing down at time t equals 1 second? Alright, so speeding up if at times vt greater than 0. In other words, at and vt have the same sign, right? Slowing down if at times vt less than 0. In other words, at and vt have the opposite sign, right? So we need to calculate v of 1 is going to be 9, right? This guy is greater than 0. Now a of 1 we got above is going to be 12 greater than 0, right? A of 1 and v of 1 have the same sign. The car speeding up, right? Now question C. Find the distance in feet that the car travel over the time interval 0 to 4. Alright, so the distance is the interval of the absolute value of v of t, right? From 0 to 4, so we have, so from 0 to 4, we look at this function right here. V of t is above the axis, right? So it's going to be positive, right? So we can remove the absolute value sign without changing anything. And we just integrate this one, so it's going to be 1/5 t to the 5th minus 8/4 t to the 4 plus 16 over 3 t cubed, evaluated from 0 to 4, right? And we just substitute 4 for t, right? If you substitute 0 for t, it's going to be 0, right? So it's going to be, you just leave the answer like this, right? Now question D. Find the average velocity of the car over the time interval 6 to 12. Alright, so we need to use the average formula. Now in this situation, A is 6, B is 12, right? So it's going to be 1 over 12 minus 6 integral from 6 to 12. Now 6 to 12, we're going to use this function, right? It's going to be 1 over 6. Now we need to take antiderivative of this one, right? Remember, antiderivative of cosine of AS plus B ds is going to be 1 over A sine of AS plus B plus C. So keep that in mind. So this guy turns out to be 1 over pi over 3, which is 3 over pi times 10 is going to be 30 over pi sine of pi over 3t, right? Minus 10t evaluated from 6 to 12, right? So it's going to be 1 over 6. Substitute 12 for t. So we have sine of 4 pi minus 10 times 12 is going to be 120. Substitute 6 for t. So it could be 30 over pi sine of 2 pi minus 60, right? So we have 1 over 6 times sine of 4 pi equals 0, right? So this guy turns out to be negative 120. Subtract sine of 2 pi equals 0, and this could be minus 60, right? So the answer is negative 10 feet per second. Question 6. The function f is twice differentiable. The table gives values of f and its derivative f prime at selected values of x. Question A. Find the limit of Ls over s when s approaches 2. Or say that the limit does not exist. Alright, so this guy is the same thing as limit when s approaches 2, right? So when s approaches 2, Ls approaches 3, right? So it could be over s equal 2, right? Now question B. let g of x equals f of s, find g prime of 2. Alright, so we need to take derivative g prime of s. It's going to be f prime of s times f prime of f of s, right? G prime of 2 is f prime of 2 times f prime of f of 2, right? So f prime of 2 is 4 right here, times f prime of f of 2. f of 2 equals 3. So it's going to be 4 times f prime of 3 is 9, right? So the answer must be 36. Now question C. Let h be the differentiable function such that h of 0 equals 10, h prime of s equals f prime of 3 of s. We need to solve for h of 2, right? So we're going to use the fundamental theorem of calculus, right? So we have the integral form 0 to 2 of h prime of s ds, right? We need to take advantage of this information right here. It's going to be h of 2 subtract h of 0, right? So then h of 2 equals, so h of 0 is 10 right here, plus antiderivative of h prime of s, actually this guy right here. If we take antiderivative of this one, it turns out to be 1 over 3f of 3s, right? So it's going to be 1 over 3f of 3s evaluated from 0 to 2, right? So it's going to be 10 plus 1 over 3f of 6 subtract f of 0, right? Now we substitute value f of 6 is 5. f of 0 equals -1, right? So we have, so the answer must be 12, right? Now question D. Let k be the function defined by k of s equals this guy, find k prime of s. So k prime of s is, take derivative of this one, right? So it could be s squared times f of s, right? Now question 2i. Find k double prime of 3. So k double prime of s equals, we're going to use the product rule, right? So we have 2s times f of s plus f prime of s times s squared, right? So we substitute value k double prime of 3 equals 2 times 3 f of 3, right? Plus f prime of 3 times 3 squared, right? 2 times 3 equals 6. f of 3 is 8, right? Plus f prime of 3 is going to be 9 times 9, right? So it could be 48 plus 81, and it's going to be 129, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.